Okay, in this video we're going to be looking at mass density and volume, and then we're also going to go on and look at pressure, area and force. So the first thing we're going to look at is density, mass, volume. Now again, there's a memory triangle, as I call it, for much like we did for distance, speed, time, just for remembering these things. So we will look at how we do this. Now this memory triangle, first of all, you've got to remember how you actually get the M, D and the V. M on the top and the D and the V on the bottom. So how I remember that is I think about the units of density. So density, for example, the units would be grams per centimeter cubed, for example. So it looks like you've got the grams are being divided by the volume. So the grams are the mass, so that's how it tells you that the mass goes on top. Okay, so I get that really from the units of the density. So mass is on the top, and then you've got your density and your volume on the bottom. So M on the top, density and volume on the bottom. How you use this triangle, if I just get myself a wee shape here, I'll just show you how we use it. If you want to use this, what you do is you would cover up the M, and then what you're left with is D and V on the bottom. So to find mass, it's going to be D times V. If I want to find my density, I would cover up my D, and what I'm left with is M over V, so mass divided by volume. And if I want to find my volume, I cover up my V, and what I'm left with is M divided by D. So that's how we use our memory formula. Much like your distance, speed, time formula, exactly the same idea. Okay, right, we're going to go down to, first few thing, we're just going to look at the units. Now, why this is important is that the units must be consistent. So you really look, we're going to look at the first one. We've got our density is in grams per centimeter cubed. So if your density is in grams per centimeter cubed, that means your mass must be in grams and your volume must be in centimeters cubed. So volume, centimeters cubed, mass must be in grams. So just add in wee g here for your grams. For the second row here, we've got our mass is in kilograms, our volume is in meters cubed, so your density has to be in kilograms per meter cubed, and that is it. Okay, over the page, and we're on example 11. And it says in this question, a block of mass 349.2 grams has a volume of 36 centimeters cubed. Find its density. So every single time here I'm going to write down my memory triangle to keep me right. My mass is on top, I've got my density and I've got my volume. And then what are we trying to find in this question? We're trying to find its density. So cover up the D, and what you're left with is M on the top and V on the bottom. And then we're just going to fill this in. So 349.2 divided by my volume, which is 36. And then you do this on your calculator and you will get 9.7 grams per centimeter cubed. Example 12, it says the density of a material is 2.4 kilograms per meter cubed. Find the mass of 5 meters cubed of the material. So again, I'm going to write down my memory formula. It was M, D and V. And if you cover up M, what you're left with is D times V. So M is equal to D times V. And then again, we're just filling in. So density was 2.4 and the mass was 5. So it's 2.4 times 5. And if you do that, well, you can do that without a calculator, but if you do that with a calculator, you're going to get 12 kilograms. Just while we're on this, just check we're okay with the units. In this one, the units were kilograms per meters cubed, and the mass was in meters cubed. That means your volume was in meters cubed. That means your mass is going to be in kilograms. Okay, the next question, next example is example 13. Example 13, we have got a cylinder of radius 12 centimeters and height 140 centimeters, has a mass of 300 grams, and it says to find its density to 1 decimal place. Now, the problem here The problem here is if you have a look at the units are in kilograms per meters cubed. So that means our mass, so the units of density are kilograms per meter cubed. That means we need to have our mass in kilograms. We need to have our volume in meters cubed. So first thing we're going to say is our mass in this question. M in this question is 3,500 grams. So if you convert that to kilograms, you're going to get 3.5 kilograms. Okay, so remember, to convert from grams to kilograms, simply divide by 1,000. Right, a wee bit trickier for our cylinder. So we're going to do a diagram for a cylinder. So for your cylinder, you've got a radius on the top. So there you make a wee cylinder there. There you've got a cylinder. Your height of your cylinder is 140 centimeters. If you convert 140 centimeters to meters, you're going to get 1.4 meters. And your radius is 12 centimeters, so that's going to be difficult the way I've drawn it. My radius, I'm going to just do another wee arrow here to here. That's going to be 0.12 meters. 12 centimeters in meters is 0.12. So the volume of a cylinder is pi r squared h. So in this case, it's pi times 0.12 squared times your h, which is 1.4. And if you do that out on your calculator, what you will get is an ugly looking number, 0.063345, and that's going to be meters cubed. Okay, so we worked out our mass in kilograms. We've got our volume now in meters squared. Why we were doing this, remember, is just because the units of density were kilograms per meters cubed. Sorry, we had our volume in meters cubed, so our units of density are kilograms per meters cubed. We are now ready to answer the question. So we'll write down our wee memory formula again, M, D, and V. We want to find D. If you cover up D, you're left with your mass divided by your volume. So all you're doing here is your mass, which is 3.5 divided by 0.063345. So I've gone to loads of decimal places, so I'm definitely going to be right. And when you do that, I got an answer of 55.3, and that was kilograms per meter cubed, and that was to 1 dp. So we can fill that in, 55.3. I know I'm definitely right because I've used so many decimal places in my working out. Okay, example 14, two more examples to go on our mass density volume just. It says a cube of mass 0.384 kilograms has a density of 6 grams per centimeter cubed. Find the length of each side of the cube. Now, when I look at this, first thing I see is a problem. I've got my mass is in kilograms, but my density is in grams per centimeter cubed. So the first thing I'm going to do is I'm going to change my mass into grams. So my mass is equal to 0.384 kilograms. Let's convert that. That's going to be 384 grams. And that's what we'll be using. I'll write down what we've got. My density is 6 grams per centimeter cubed. And then what we want to do is find the volume. So we'll do a wee triangle again. Mass on the top, density and volume on the bottom. And what we're trying to find is volume. So volume will be equal to M divided by D. Okay, so if we go on with that and fill that in, our mass was 384 grams, our density was 6 grams per centimeter cubed, and then we divide, and if you divide, you get 64 centimeters cubed. Okay, so if you've got to 64 centimeters cubed as your volume, you've got the bulk of the marks of the question, but you haven't got all of the marks. Read the question again, and it is good exam practice to always read the questions. It says, a cube of mass 0.384 kilograms has a density of 6 grams per centimeter cubed. Find the length of each side of the cube. So it doesn't actually ask us to find the volume. it asks us to find the length of each side of the cube. So we're going to do a wee diagram. Again, so this is just a wee cube. So to draw a cube, just do a wee square, and then cast 3 lines back, and length goes up. Now you've got a beautiful cube, and we've got x, x, and x. So we're just calling every side of this cube x. So we know then how you find the volume of the cube then would be the length times the breadth times the height. So in this case, x times x times x. So we can say the volume is equal to x times x times, we'll just write that out, x times x times x. So your volume is equal to x cubed. But we also know that 64 is the volume, so 64 equals x cubed. And what is the opposite of cubing something? The opposite, or the inverse of cubing something, is cube root. So we can do cube root of 64, which you can do on your calculator, or if you just know it, the cube root of 64 is 4, and the answer then would be centimeters, and that is it. Okay, this is our last example on density, mass, and volume. In this one it says a cube has a mass of 200 grams and a length of 2 centimeters. Find the density of the cube in grams per centimeter cubed. So for A, we're going to just say it has, the mass is 250 grams, and the volume, we're going to have to work it out. The length of one side of the cube is 2, so it's going to be 2 times 2 times 2, which is going to give you 8 centimeters. Once you've got your mass and your volume, you can find your density. Density is equal to mass divided by volume. And if you do that, you're going to have 250 divided by 8, which works out to be 31.25 grams per centimeter cubed. Okay, to do this next question, what we're going to do is we're going to just convert our grams at the start, our mass, into kilograms. So we're going to rewrite 250 grams is going to be 0.25 kilograms. To get my volume in meters cubed, I'm going to write it as 0.02 times 0.02 times 0.02, and that's going to be meters cubed. And if you work that out, that's going to work out, and it came out on my calculator as 1 over 125,000. So that's meters cubed. Okay, that looks weird, but you've got a fraction button in your calculator, so you could just use it to do this question. Your density, remember, is mass divided by volume. Just write it a wee bit differently this time, which is going to be 0.25 divided by the 1 over 125,000. And when you do that, you get your density to be 31,250, and that the units are kilograms per meter cubed. Okay, there is also another way of doing this question. We have got our answer to part A gave us our units, which were 31.25, and that was grams per centimeter cubed. What we could do then is convert that into, we'll go into first of all grams per meter cubed. Now, to do that is not terribly easy. To convert from grams, from centimeter cubed to meter cubed, what you've got to do is multiply by 100 times 100 times 100. So you've really got to multiply by 1 million. So there's 1 million tiny wee centimeters cubed in a whole big meter cubed. If you were to draw it out, don't put this into your notes, please. But if I was to do a diagram here of a meter cubed, so that's 1 meter by 1 meter by 1 meter. But if you write that as centimeters, that's 100 centimeters by 100 centimeters by 100 centimeters. So there's a wee tiny centimeter cube there right in that corner. So there's a 100 of them this way, there's 100 of them this way, and there's 100 of them this way. So 1 meter cubed is the same as 1 million tiny wee centimeter cubes. So that's fairly tricky. So that means when we convert, if you want to do this conversion, you could multiply this by 1 million and see what you get. So multiplying by 1 million, so we've got, what have we got? 31.25 times 1 million, and that gives you 3125 with 4 zeros. So that's the number of grams per meter cubed. And then convert to kilograms per meter cubed by dividing by 1000. So if you divide that by 1000, you get 31250 kilograms per meter cubed. So there's just to show you the two ways of doing it, but I know for sure which method I prefer. The first method is much easier in this example. Okay, next thing we're going to look at is another compound measure. This is pressure, force, and area. So pressure, the units of pressure are force per meter squared. Now this is, looks like you've got your force being divided by your area. So that's why you've got your force on your top, your area on your bottom, and then what you're left with is your pressure. So that's how you arrive at your formula. So F on the top, and then P and A on the bottom. F stands for force, P stands for pressure, area stands for area, and the force is in newtons and the area is in meters squared. Okay, it says in this first example, it says find the pressure caused by a force of 78 newtons acting on an area of 26 meters squared. So let's do a wee triangle just so we've got it so we can see it. We want to find the pressure. So the pressure is equal to your force divided by your area. So in this case, 78 divided by 26. And if you do that out, you'll get 3. And the units of pressure are newtons per meter squared. And that is it. Our next example says a force acts on a circular area of radius 50 centimeters, creating a pressure of 8 newton meters squared. Find the force. First thing I notice is my units of pressure are newtons per meter squared. So I need to find my area in meters squared. So it's a circle. The area of a circle, first of all, we'll say our R is equal to 0.5 meters. So I've converted my radius into meters. So 0.5 meters. The area of a circle is pi r squared. So in this case, that's going to be pi times 0.5 squared. And when I did this on my calculator, it gives me an answer of 1/4 pi. It actually gives it as pi over 4. This is a perfect answer. So don't change this. Work with pi over 4 on your calculator. We can still see our wee memory triangle up above, so we'll not bother to write it again. Force is what we're looking for, and it is equal to P times A. So in this case, it's going to be 8. Our pressure was 8. And our area, we've just worked it out to be pi over 4. Do that on your calculator now, please, and see what you get. You should get a perfect answer of 2 pi, which works out to 2 decimal places as 6.28 newtons, and that was to 2 decimal places. Okay, the last of our pressure, force, area examples. It says a force of 0.16162 kilonewtons exerts a pressure of 4.5 newton meter squared on a square area. Find the perimeter of a square area. It's a bit of a tricky question here. First of all, we've got to get our force. Force is 0.162 kilonewtons. So a kilonewton means 1,000 newtons. So that's going to be 162 newtons. 162 newtons. Let's just write down our pressure is equal to 4.5 newtons per meter squared. If we do a wee memory triangle, what we want to find in this question, first of all, is area, is force divided by pressure, which is 162 divided by 4.5, which works out to be 36 meters squared. And then we'll need to do something else to get to our final answer. Right, so we've got to the point we've got our area is equal to 36 meters squared. It asked me in the question to find the perimeter of the square. Not too sure what I'm going to be doing, so I'm going to draw a diagram. So here we have a pretty ropey square, but we've got a square nonetheless. It is 36 meters squared. And what I do know about a square is the sides are the same. So if that side is x, that side is also x. So my area was equal to 36. That means 36 is equal to x squared, which means I was very badly set out. So I'll just write x squared is equal to 36. Then x is equal to the square root of 36. So x is equal to 6. Okay, and that's going to be in meters. Again, we have found, almost got to the answer. We found the length of one side. Haven't completely found the answer. We'll just say our perimeter. I'm just writing the full word perimeter instead of saying P just to avoid any confusion with pressure. My perimeter is equal to 4 times 6, because there's 4 sides on the square, which is going to be 24, and the units would be meters. And that is, oh, that's not our answer. Have a look at the question. They want the answer in centimeters. So we've got to convert that into centimeters. That's a bit weird. That's very unusual for them to do that. That's going to be 2,400 centimeters. So fill in 2,400 as your answer. Okay, the very last part of this video, we're just going to look at some other compound measures. Now, they will give you a wee bit of information in the question if they're talking about these. So it's not like we'll have to learn all of these new ones. They're just ones that you may have seen, and you may have seen these in other subjects, such as biology or such as geography. So just have a wee look at a few of these. So in example 19, it says Bruno's heart beats 4,410 times in 1 hour 10 minutes. Find his average heart rate. Now we need to understand what this means. BPM means beats per minute. So BPM means beats per minute. So the answer to this one, it's going to be the number of beats, which is 4,410. And then to convert your time into minutes, then we're going to have to then convert this into minutes. So this is going to be 70 minutes. And then if we do that on our calculator and see what we get. So 4,410 divided by 70 is equal to 63 BPM, and that is it. So the only real trick in that one, you had to convert your time from hours into minutes to give you your answer of 63 beats per minute. Okay, example 20 and 21. Examples 20 and 21 are very like examples you may have seen in geography, where you're talking about population density. So population density then really is about how many people there is per area of land, and the number of people is normally in millions, and the area of land is normally in kilometers squared. So in this question, we'll just write down formula. We'll just write down population density, abbreviate population to POP. So POP density is equal to we've got 1872 and then 4 zeros. So convert that into the whole number of people, then divided by 90,000. And then that works out as a population density of 208 people per square kilometer, which doesn't sound like an awful lot. Okay, example 21, we have got population of a town is 32,000. The population density is 200 people per kilometre squared. Find the area of land. So we're going to use this to find a wee memory triangle for us. Now it looks like you've got people on top being divided by area. So you're going to have, we'll just say people. And then we've got area. And we've got density. So that's our memory triangle in this case. So in this case, it says find the area, the land area of the town. So we'll just say area is going to be equal to the people divided by the density. People, we could have written population instead, might have been a more better way of saying it. So we've got our area is equal to our number of people, which is 32,000, divided by our density, which is 200. And if you do that, you're going to get 160, and the units are going to be kilometers squared. Okay, it says in this question, the rate of temperature drop overnight on Mars was recorded as 7.8 degrees per hour. How long will it take for the temperature to drop 21.45 degrees at this rate? Give your answer in hours and minutes. So your rate is equal to degrees C per hour. So that means you've got your temperature on your top, and then you've got the rate, and then you've got your time, and that's how we're going to fill in our wee triangle. So what we're looking for in this question is you're looking for your time. So it's going to be equal to the temperature divided by the rate. So that's going to be 21.45, and the rate was 7.8. And if you do that, it gives you 2.75, and that's going to be 2.75 hours. Another way of saying 2.75 is 2 hours. 2.75 hours is 2 hours. 2 3/4 hours. 2 3/4 hours is going to be 2 hours and 45 minutes. As you know, 3/4 of an hour, 3/4 of an hour is 45 minutes. Okay, this is a very tricky example to finish off. It says a car can travel 324 miles on a full tank of fuel, which is 9 gallons. What is the car's efficiency in miles per gallon? If the cost of fuel is £4.50 per gallon, what is the cost of travel in pence per mile? So we have a heck of a lot to do in this one. So we'll just say in this case the efficiency, and that's in miles per gallon, is equal to your miles divided by gallons. So in this case, that's 324 and divided by 9, which was your number of gallons. So that's 36 miles per gallon. So what we want to do is work out his cost. So the cost then is going to be the number of gallons times whatever the cost was. It was £4.50. So the number of gallons used we need to find. So we need to find our number of gallons. So number of gallons is equal to the 324 divided by 36, which is 9. We were even told in the question, forget about that, we were told the number of gallons in the question. Number of gallons was equal to 9. So it means our cost is just equal to 9 times 4.5, which is £40.50. And then we'll just convert that into pence, which is 4,050 pence. The last thing you've got to do is find your cost per mile. Cost per mile is equal to, we had 4,000 4,050 pence, and the number of miles that he travelled was 324, which works out as 12.5, let's say, pence per mile, and that is us.